all matter is made up of very tiny particles which move around differently depending on the amount of energy they carry. In this chapter, there are three distinct states of matter: solids, liquids, and gases. In relative terms, a solid is an object that has a definite rigid shape. The forces between the particles are dictated by the amount of energy the particles carry. A solid has relatively weak particles that vibrate in fixed positions. They also have a high density, so they cannot easily be compressed, and inversely, cannot expand to fill up more space. The particles in a liquid contain more energy than a solid, but less energy than a gas. When we supply more energy to a solid, the particles get more excited and thus have more kinetic energy, until eventually the forces are too weak to hold the shape of the solid, though they still do stick to each other, so they still have a high density. This means that liquids do not have a rigid shape, but are not able to compress easily like a solid. Liquids cannot expand to fill all parts of the container, but it is more than a solid can, and liquids do flow and so are defined as fluids. A gas is an even higher energy state of matter. The particles in a gas have so much kinetic energy that the forces between them are weak with a low relative density. They can easily be compressed, have no definite shape, expand to fill all spaces, and are fluids because they flow. The amount of energy needed to change a unit mass of an object by a unit temperature is given by the equation Q equals to mc delta T, or energy is equal to the product of mass, specific heat capacity, and change in temperature. Now moving on to gases. The gas laws state that the particles in a gas are moving in a completely random, unpredictable way. Each individual molecule of a gas exerts a tiny force when it hits the wall of a container. The collective force of the frequency of collisions is the pressure of a gas. Scientist Robert Boyle in the 17th century discovered that the pressure is proportional to the inverse of volume, 1 over V. This is expressed in the equation P1 times V1 is equal to P2 times V2, assuming that temperature is constant. The relationship between pressure and temperature means that if you keep volume constant and decrease the temperature in a system, there is a point where the pressure reaches zero, called absolute zero. This temperature is negative 273 degrees Celsius, or 0 Kelvin.